Hello and welcome. I am Harit, Doshi, CEO of Omniply Technologies. I'm delighted to speak to you about how Omniply is enabling ultra-low stress, flexible display manufacturing. I will be joined by Dr. Humaira Taj, Omniply's co-founder and CTO, who will speak about Omniply's advantages over the other technologies. Making rigid flexible. High performance flexible displays today are first made in a rigid form and then converted to its final flexible form. This is accomplished via a liftoff process, typically a laser liftoff process. Typically, a 15 to 20 micron polyimide substrate is used to construct an OLED display, which at the end of the process is then released from the rigid glass carrier, which provides stability during the manufacturing process. The laser liftoff is a current default technology, but has many challenges, including size limitations to half Gen 6 and others like high cost, maintenance, yield, and scale up, which Humaira will discuss in more details. This delamination is a critical and yield determining step for fabrication of most high performance flexible electronics, especially if you're building on a thin film substrate. As display manufacturers are now scaling towards Gen 8.5 from Gen 6 lines, this presents even a greater challenge to scale the current liftoff technology. It is no secret that we are spending more and more time on our mobile devices, and the boundaries between a mobile phone and a tablet is fading away rapidly. The mobile phone display size has continued to increase to a point that now, to have best experience and functionality, you need the size of a display to be larger than the footprint of the phone that you can put in your pocket, to a point that apparel makers have had to design the pocket sizes to accommodate larger phones. These are few of the many examples of flexible phones that are available on the market today. Companies are working diligently to address some of the challenges with reliability, scalability, costs of flexible and foldable displays. It is anticipated that in a couple of years, all the major cell phone manufacturers will have a flexible phone offering on the market. And the market will continue to grow approximately 10x in terms of units, according to DSCC. The future is changing fast. A few years ago, there was a question if OLEDs are going to replace LCDs. For some of the applications like automotive, that is no longer a question. The design, the form factor freedom with flexible OLEDs, enhanced performance, now allowing shape the future of bendable and curved and rollable display applications. While we may have seen these products announcements, it is just the beginning of a mass market adoption of flexible OLED displays. Omniply's technology, which was invented at Stanford and Purdue, will not only change the manufacturing for flexible displays, but will also enable many other flexible electronics, such as thin film sensors, thin ICs, thin plasmonic films with nano features, where some of these applications cannot use the laser liftoff technology, as the flexible substrates that are being used cannot withstand the heat or the stress during the laser liftoff process. I will now pass it to Dr. Humaira Taj, who will talk about Omniply technology.
Thank you for that introduction. So now I will talk a little bit more into the different kinds of delamination techniques that are commonly used or have been developed in the industry or research entities, and some of the challenges with each of these technologies, and then dive a little bit deeper into what our technology is all about. So you can see on this table, these are pretty much, like a summarized version of all the major delamination methods that have been